Okay, so question 27 says, after a snowstorm, city workers remove an estimated 10,000 cubic yards of snow from the downtown area. If this snow were spread in an even layer over the entire rectangular football field shown below, about how many yards deep would the layer of snow be? So the question gives us a picture that looks like this, and is the end zones of the football field, and it says it's 50 or 53.5 yards across. So from the top here to the bottom here, it's 53.5, and from one end zone to the other, it's 100 yards, and from the end zone to the beginning of the end zone, the end of the end zone to the beginning of the end zone is 10 yards for each one. So this whole length is equal to 120 yards, and it wants to know if we put 10,000 cubic yards of snow, how high would the snow stack up? And if you could imagine the height of that snow being piled on top of this field coming out of the computer screen towards you, what would that height be? What would that h be? It's sort of hard to draw it in a two-dimensional plane, but okay, so you have 10,000 cubic yards total of snow to place on this football field, and we know the volume of a rectangular prism is equal to the width times the length times the height, because we're basically trying to find the height of this volume, because when you think about it, we're going to have this field like this, we're going to have this length, or this length right here. You can imagine this 120 yards being this 120, this being the 53.5, and then we have some height to this that would look like this, to where the snow would be piled up on top of, and it would look like this, and we're trying to find this h value. We already have the width, which is this 53.5, we already have the length, and we're just trying to find this height. And we already have the total volume, which is this 10,000, so if we wanted to, we could just plug in the values. 10,000 is equal to 53.5 multiplied by 120 times the h. And we can use simple algebra to solve for h, and we get that 10,000 divided by 53.5 times 120 is about equal to 1.558. So it'll be 1.558 yards deep, but the answer says will it be less than 1, between 1 and 2, between 2 and 3, between 3 and 4, or more than 4. We can clearly see that h is greater than 1 but less than 2, so it leaves us with choice B, between 1 and 2. Okay, we'll go on to question number 28 now, and it says, one second, let me just invert the colors here. Okay, 28 says the hypotenuse of a right triangle PQR shown below is 16 feet long. So I'll draw this triangle. It's a right triangle, so all these sides are straight. So that's a right angle. This is angle P, Q, Q, and R. And it says this length is 16. And it says the sine of angle P is 3/5. And about how many feet long is side length QR? So we're trying to find this side length. We'll call that x. It says the sine of P is equal to 3 divided by 5. And if you watch the last video, you'll remember that the sine of any angle is equal to the opposite side length over the hypotenuse. So, and this the sine will always be constant for any given angle when the sides are not moving and the angles are not moving or changing. So we can see that the sine of p, in this case, will be equal to x over 16, right? Because we're just taking the opposite side length and dividing it by the hypotenuse. But the question says that this will be equal to 3 over 5. So if we wanted to, we could just cross multiply to solve for x. We get 16 times 3 equals 5x, and that is equal to 16 times 3 equals 48 equals 48 times 5, or equals 5x, and x will be equal to 9.6. So you can see we just created this proportion here and then solve the equation. And that's the answer. X is equal to 9.6. Oh, x is equal to 9.6. And we'll go on to question 29 too. This one requires a bit of drawing, so let me just draw this out. It says the graph below shows the number of cars assembled last year in 4 cities to the nearest 5,000 cars. According to this graph, what fraction of the cars assembled in all 4 cities were assembled in Coupeville? So it gives us a graph. This is question 29. It gives us a graph that says cities and lists cities, and we have Cartown, which is, I guess, appropriate, Coupeville, Truck City, and Sedan Falls. And then it tells us the number of cars assembled, and it gives us this key that says each, it's supposed to be a car. Okay, well, that's my version of a car for the time being. And each car is equal to 10,000 cars produced. 10,000 cars produced. And Cartown has 4 of these cars. I'll just make them boxes to save time, which is basically what they were originally. But Coupeville has 2.5 of these. 2.5. Truck City has 1, or no, Truck City has 2 of these, and Sedan Falls has 1.5. So we can, and it wants to know what fraction of all the cars assembled in all 4 cities were assembled in Coupeville. So first we want to see how many cars total were produced in all 4 cities, and then we can divide that, or we can divide the number of cars made in Coupeville divided by that total number. So we see Cartown made 10,000, 20,000, 30,000, 40,000 cars. 40,000 cars. Coupeville made 10,000, 20,000, 25,000, because that half box counts as 5,000 cars. Truck City made 10,000, 20,000, 20,000 cars, and Sedan Falls made 15,000 cars. And if we add this up, we will get 100,000 cars produced total. So by all 4 cities, 100,000 cars were produced. And it wants to know what fraction of this entire thing, all these cars, were produced in Coupeville. So we can just take the number of cars made in Coupeville, 25,000, and divide it by the 10,000, or excuse me, the 100,000. And that will be equal to 1/4. So 1 out of every 4 cars that was produced in these 4 cities came from Coupeville. And that's the answer. I'll see you in the next video.